So this section here, right, we are exploring the equation of linear function. So what do we mean by equation? So the idea of equation is like a name. So it is the name of a line. So it's like each of you got a name. Okay. So everyone got a name. So every line also got a name. So we got three types of linear function. So the first type of linear function is the one that has two features. So this type, right, the first type is the one that comprises of gradient. So in any case, right, sometimes if this is the first time you are thinking, so what exactly is gradient? So gradient is the steepness. How steep is the line? So we will judge a line by the steepness. So for example, right, if you also like this line here, okay, so maybe this line I will call it gradient 5. This line is quite steep. If I draw you another line here, this line doesn't look so steep. It's a bit flatter. So you imagine a mountain. So if I ask you to climb this mountain, I think you'll feel a bit scary. But if I ask you to climb this mountain, I think you feel like, okay, not so bad. So this one, right, I think the gradient is a little bit not so steep. It's gentler. So maybe I'm expecting the gradient to be like a 3. Okay, so this is the idea of gradient. So some of you may be thinking, so what exactly is gradient? It's the steepness. So there can be positive gradient or it can be negative gradient. So negative gradient looks like this. So this is the negative gradient going downwards. So again, right, this going downwards is very steep. Can you imagine? It's like if you're going to go down a slope like this, right? You feel like you're going to topple over, right? So this is a very steep gradient compared to this one. This one not so steep. You realize that you feel like you can slide across. Okay, so in the upper side, right, you will be playing around with this feature. So at lower side, you just have to understand the idea of steepness. So we measure steepness by numbers. The bigger the number, the more steep it is. So this one is quite steep downwards, right? It's quite steep, but it's in a downward position. So I'm expecting that maybe this gradient is a -4. Then the other one that I don't feel that is so steep, okay, I think it can be a -2. So will you need this idea of comparing steepness, right? Yes. I think all of you are old enough already, so maybe you don't go playground so often. You know, if you go playground, certain thing you got to climb up very steep. So that the idea of steep is the gradient. So gradient can be positive gradient, it can be a negative gradient. So the bigger the number it is, right? The more steep it is. So we will characterize a linear function with gradient. That means I will judge a line by the gradient, and I will also judge a line by the y-intercept. Y-intercept is where the line cuts the y-axis. So there will be these two features, and these two features is encompassed into the name of the line. So they put it here. They put the gradient here. They put the y-intercept here. Okay, so this is always a very confusing part. So I'm going to focus a little bit more on this one. So the y equal to mx plus c. That is the name of a line. So in the name of a line, we know that this is the gradient. And the gradient is always attached to X. It's like you clip something to, you clip a magnet or something. So you clip the gradient to X. Okay, so the name of a line will comprises of the gradient, will comprises of where it cuts the y-axis. So it's just like your line, your name. So each of you, right, if you look at your name, so if I look at your name, I know what to call you, correct? If I look at your name, I also know your family surname. So that is the feature of a name of a person. But when it is the name of a line, the two features will be the gradient, how steep the line will be, and where it will cut the y-axis. So it corresponds. So in a name, right, I must know something about it. From your name, I know how to call you. I know your family name. From the equation of the line, I know the gradient. I know where it cuts the y-axis. Okay, so later on, we will focus on the calculation of gradient. So if I know how to calculate the gradient, I can put into the name. Okay, so this is the most common type of linear function. The other two, right, is separately on a horizontal line. So a horizontal line is totally flat. So how does a horizontal line look like, right? It looks like this. So it looks horizontal. So it's totally horizontal. So imagine this is you. So you are lying flat, you are sleeping. Maybe it's easier if you visualize that, hey, I'm sleeping here like this. You know, like you are horizontal sleeping there. Okay, so this is an extreme line. So you realize this line is totally flat. So for those of you, if you learn it in school, right, what is the idea of totally flat? That means you got no steepness. So a horizontal line, a flat line, right, has no steepness. It's not steep at all. So when it's not steep at all, right, you can like just move around very comfortably. So there's no steepness, there's no gradient. So the feature of a horizontal line will be the gradient is 0. There's no gradient at all. No gradient means there's no steepness. You are walking on horizontal ground. But the name of a line will be simplified. The name of a line, instead of mx plus c, right, it will be y equal to k. So I want you to think about it. So the gradient is 0. So just now I said that the gradient is always attached to x. So let's think about it. So the gradient is 0 and the gradient is attached to x and you are cutting the axis at k. So the gradient is 0. So it is still a magnet that you attach to x. But we know 0. 0 times anything is a 0. So that's why
what is K?
K is the number that cuts the y-axis. So for example, maybe it cuts at 5. Okay, so and now is I just put it in a general case. I don't know where it cuts. So for a horizontal line, the name is dependent on where it cuts the y-axis because it's a gradient 0. So horizontal line is like you sleeping. Okay. Okay, so this is the second type of linear function. So this second type, right, has zero gradient. There is no steepness at all. Where else, if you go to the last type, it is a totally vertical line. So it's a total vertical line. So what is the gradient of a vertical line? So a vertical line is like you standing up straight. So this is how a vertical line look like. So a vertical line doesn't have y-intercept because it doesn't even cut the y-axis. So this is the extreme situation. So the line is so steep until that it became vertical. So what about the gradient, right? So in this case, right, the gradient is undefined. Later on, we will show the undefined. So undefined means on your calculator, it shows the math error. It will really show a math error later on when I teach you how to calculate. And because the vertical line doesn't cut the y-axis, it cuts the x-axis. That's why it has a special name, x equal to h, depending on where it cuts. So if it cuts at 5, then it will be x equal to 5. So a vertical line doesn't have a y-intercept. And it is so steep until it became vertical. So we will consider the gradient undefined. So when you press calculator on this, you will get a math error. So in math, anything undefined is a math error. Okay, so it depends on how your calculator show you on the math error part.